Hey, what's up everyone? Shane, aka Wild Poker here. As you can see on the title slide, we're going to be talking about some basic poker math today. I've had some people talking to me about it and asking me about it in the forums a little bit more recently, and I said I'd throw together a video, so I made a PowerPoint and we're going to go through it, and hopefully everyone that's been working on figuring out basic poker math can learn a little bit from this and use it to help their games. So here we go. First thing we're going to be talking about is ratios and fractions. I think this is key. You need to be able to understand both of these and how they're interchangeable and how they work very well in order to be able to quickly calculate the things you need to at the table. So, first, ratios tell you how much there is of each thing or how much is of one thing and is not of that same thing. And we'll give an example in a second to hopefully make that more clear. Fractions tell you how much something is out of the whole. So it tells you how much one thing is out of all the things. So it's similar, as you can see, but it's not exactly the same. So let's look at this example here, a very simple example. We've got a circle, and you can see it's divided into three parts. Two of them are blue, and one of them is white. And so what is the ratio of blue to white? And you can see how it's kind of, we want it written there. Blue, white in the numbers. And I kind of already gave the answer when I was describing the circle. 2 to 1. 2 parts blue, 1 part white. So that's our ratio of blue to white. And we could also, if you wanted to phrase the question, what is the ratio of blue to not blue? How much is blue, how much is not blue? So the ratio of blue to not blue would be the same number, 2 to 1. So it's going to be able to tell us that kind of information. Just based on how we phrase the question is how we're going to put those numbers and how we're going to answer it. Now, if you wanted to know how much of the whole circle is blue, so how much of the circle is blue out of the whole thing? 2/3. You have 3 parts and 2 of them are blue, 2/3. So we can see here that these ratios and fractions are telling us very similar information. But they're answering different questions, so it's not exactly the same. But because the information is similar and because it's relatable, we're actually going to be able to quickly go back and forth between them. That's something that we can do, and it's something that you actually need to be able to do at the table. And the quick way to be able to do that is to notice that a ratio tells you how many parts make up the whole. 2 plus 1 equals 3. So we have 2 parts blue, 1 part white. That makes the total circle of 3 parts. And then depending on the question, so on the question we had before, what is blue? It's 2 of them. If the question was what is white, it's 1 out of 3. So in order to go from a ratio to a fraction, you just add up the 2 numbers, and that becomes your denominator. And that's very important to know that. And we'll do more practice with this down the road as we go through these slides. So let's talk a little bit about pot odds. So pot odds is your ratio of risk versus reward, and is usually written as reward risk. So you'll hear a lot of people say, I'm getting 2 to 1, I'm getting 3 to 1, things like that. The reward is going to be the 2 or the 3, and the risk is going to be that 1 that they're throwing out in those cases. And let's do a very simple example here to kind of get a little bit of a feel for this. So the pot is $1 on the river, and your opponent bets $1. So what are your pot odds? I'll give you guys a second to think about that, and time's up. Okay. So your reward is $2 and your risk is 1. So where did I get the 2 from? Is the pot was originally $1 and your opponent bet another dollar on top of that. So the pot now becomes $2, and when you win, you get to win that entire $2 pot, and your risk is 1 because you only have to call the opponent's $1 bet. I'm sure most of you think this is very obvious, but we're just taking it step by step just to make sure we cover all our bases. So after we see this, we write it out in that reward : risk ratio, and we get 2 to 1. And I will let you guys know, I mean, you can switch these around and put it in whatever order you want, as long as you know what order you're putting it in. So if you want to say I'm getting 1 to 2, and in your mind it's risk and reward, that's fine. But you have to be very clear about what question you're answering and how you're constructing your ratio. So as long as you're clear about that, it doesn't really matter. And as long as you're consistent all the way through all of your equations, it doesn't really matter. But this is the way it's normally done. So what does this tell us? This tells us how often we can win versus lose in order to break even on our risk. So a very easy way to think about this is we can lose 2 times for every 1 time we win, and we're going to be breaking even on our bet. So we can lose, yeah, that's just the way that, another way to think about it. If we lose 2 times and we win 1 time, and we just keep doing that over and over and over with this scenario here, we're going to basically never lose any money and never win any money in the long run. So something, that's a way that might make it easier for some of you guys to think about. You can think risk reward, you can think lose win. We'll keep talking about these same things over and over again throughout this this little presentation. Okay, so let's go to a slightly more realistic example and try to make it a little more difficult and try to calculate some of these numbers here. So we get a pot of 164,781, and our opponent bets 121,111 on the river. So what are our pot odds? So the easy way to do this is we want to talk in terms of risk versus reward. And I'm going to give you guys a second. Feel free to pause and try to calculate it on your own if you want. Time's up. Okay. So first thing to do is you want to round down on the pot, also known as your reward. And the reason you want to round down for sure with these numbers is because usually when you're thinking about any situation about getting odds or getting a price, things like that, you want to be a little bit pessimistic because your assumptions aren't always going to be all that accurate. So if you're a little bit pessimistic and it's still a pretty clear call, then it's going to be an even better call than what you would think because you've been pessimistic with all your assumptions. So I would say try to round down. And you see how I rounded these numbers. The original pot, 160,000. His bet, 120,000. So our reward, the pot, is 280,000. And if you're playing online, it's going to put this number out. It's going to put the actual pot size out there for you, and you can just round out. So you wouldn't even have to do this math. So that's our reward. So now what is our risk? And I just round. You can round this normally, or you can round it down as well. That will make your assumption not as pessimistic if you round it down. But we'll see later that maybe there's some cases where it doesn't really matter that much. But I would just round normally as often as possible. And so we rounded it to 120,000. And now we're ready to make our ratio. And I got 28 to 12. And how I did that was I removed all the zeros. And that's going to very quickly allow us to make a more manageable, more workable ratio. So we removed all the zeros, and we got 28 to 12. And then we need to reduce the numbers to as small as possible. Again, just trying to make it more as easy as possible for us to work with. So 28 to 12, we can divide each number by 4. So we should get 7 to 3. So in this situation, we can lose 7 times for every 3 times we win, and we're going to be breaking even. So that's our lose to win ratio, our risk to our reward to risk ratio, actually, as it's written down here. So let's continue. So from this example, if we're getting the pot odds of 7 to 3, what fraction of the time do we need to break even? So I talked a little bit earlier about going from ratios to fractions, so I'll give you guys a second to do that on your own and try to work that out. Time's up. Hopefully you pause the video if you need more time. Okay. So the way to do that is either one of these, however thinking about it works for you. You want to take the times you need to win divided by the times you can lose plus the times you need to win. Or if you want to think about it this other way, you want to take the amount you're risking divided by the your reward plus the amount you're risking. Either one of those is going to, it's the exact same thing. It's just different ways to think about it or different ways to say it. Whatever works best for you. That's going to give you your fraction. So our fraction here is 3 divided by 7 plus 3, or 3/10. And then if you want to take that and make it a percentage, you just divide those numbers out and then multiply by 100, so that would be 30%. So basically I'm going to give you guys the equations. I've put these equations up a bunch of times in my stream when I've been talking about these pot odds and things, but if you are thinking about calling, you're going to do what we've been doing, what we've shown here. Your risk divided by your reward plus your risk. Another way to think about it is your amount to call divided by the pot plus your amount to call. These numbers, these equations here, are going to give you the percent of times you need to win to break even. Exactly even. So this is not a number to be a winning player. You need to be slightly better than that to be winning. But breaking even is not a bad thing. So that's if you are calling. You will never be greater than 50%. So you will never need to win more than 50% of the time. So if you get a number that's greater than 50% and you're doing an equation for calling, you've done something wrong. So always keep that in mind. And if you're betting as a bluff, how often do you fold? How often do you need to win for your risk, your bluff risk to be profitable? It's the exact same thing, just written a little bit differently. So your risk divided by your reward plus your risk, same situation. The other thing you can think about it is your bet size divided by the size of the pot that was already out there plus your bet size. So those are the equations that you will always use for pot odds. And hopefully looking at some of these fractions that I put together kind of highlighted that and showed you that with the previous example that we did. Okay. So now we're moving to calculating our equity with outs. And we're just going to talk very quickly and simply about the rule of 4 and 2. And that's all we're going to really go over with in this outs portion. So the rule of 4 and 2, what that says is if you get to see 2 cards, meaning the player goes all in on the flop, and when you call, you're guaranteed to see the turn and river, you multiply your number of outs by 4, and that's going to give you pretty close to the amount of equity that you have. And if you're only guaranteed to see 1 card, so basically the money, it's on the turn, the player goes all in, and you get, once you call, you'll get to see the river, you multiply your number of outs by 2. Pretty simple. So, for example, we have 9 outs to win the hand and are guaranteed to see the turn and river. How much equity does our hand have? So 9 outs is a flush draw, or maybe some other combinations of hands, but usually that's going to be about a flush draw. So how much hand equity does our hand have? 9 times 4, 36% equity. And we get it on the turn, we get it all in. 9 times 2, 18% equity. So let's pull up a quick equity calculator here. And we'll plug that in and we'll see how close we got with just those things. So we'll be up against aces. And we're going to give ourselves a flush draw here. We'll pick a flush draw that doesn't have any, shouldn't have many backdoor straights or anything like that. So we'll pick queen 2, try and keep them as separated as possible. Clubs. Make it difficult for me here. Okay. So we got queen of clubs, 2 clubs, ace, ace. The board, we have an 8, 4, and king. Let's actually go. If we give ourselves any like back doors, then we'll end up with a little bit more equity. So let's make sure not to do that. No straights here. So a jack, I guess we'll have a 8-10 queen. So like a running 9-10 will give us a straight. I guess there's not much we can do. It'll be close enough. So we got our flush draw. Calculate. Boom. 34% equity. What do we calculate here? 36. It's almost 35% equity. That's pretty darn close. And if we're a little bit pessimistic with our odds calculations, then boom, we're right there. So then we're going to go to the turn. And we'll put in the 4 spades. Calculate 19% equity. Showed 18% equity here. So boom, we're right there. Not too shabby. And we did some very quick, very easy math. Okay, so let's start putting it all together here. Our opponent goes all in on this ace of hearts, 6 of diamonds, 7 of diamonds flop. There was 81,290 in the pot before his all in, and he goes all in for 129,999 chips. We are looking down at our 9 of diamonds, 10 of diamonds, and this guy's a super nice dude, and it's not breaking any rules for some reason in this tournament. He can show us, and he shows us ace of spades, king of clubs. Do we call? And I would encourage you guys to pause the video now and do this math and everything on your own, and then we'll check in a second. So pause now. Okay, we are back. So do we call? So first thing, I rounded all my numbers, and I got 200,000 to 120,000. So the 200,000 comes from adding. I rounded it to 80,000 in the pot before his all in, and 120,000 was his bet size. And 80,000 plus 120,000 is 200,000. And then our risk is the amount we have to call, which I rounded down to 120,000. We removed all the zeros, so then we got 20 to 12. Divided each of those by 4 to get to the smallest number possible, and we got 5 to 3. So our risk to reward is a 5 to 3. Or actually, if you want to be 100% correct, it's reward to risk. But when we do the equation that I talked about, risk divided by reward plus risk, or how often we need to win divided by how often we can lose plus how often we need to win, and we get the fraction 3/8, which is we need to win 37.5% of the time in order for the call to be break even. So does 9 of diamonds, 10 of diamonds have that much equity? Well, let's calculate our outs and then use the rule of 4 and 2. And it'll be 4 in this case because we're on the flop. So we have 12 outs, 9 diamond cards, and then 3 8s. We want to make sure not to count our outs twice. So because one of the 8s is a diamond, we already counted it in our diamond cards. So there's only 3 remaining 8s for us to be able to count. So that's 12 outs. And when we multiply that by 4, 12 times 4 is 48%. Bam, we have a call here. And that was calculated pretty easily. I think it's something that you could pretty reasonably calculate at the table. So even with this overbet here, we can make a pretty profitable call. And let's one more time pull up the equity calculator and plug these in and see how close this 4 to 2 got us. So ace spades, king clubs. Let's just type it out this way. King clubs. We have 10 of diamonds, 9 diamonds. And the board is ace hearts, 6 diamonds, 7 diamonds. Calculate 46.9% roughly. So we overshot it just slightly with our rule of 4 and 2, but that's perfectly fine. It's not going to change things all that much. There's a very, very large gap between this number and this number here, so we're doing A-OK making these kind of calls. And that might be shocking to some of you guys. This is a reasonable size overbet, and we're still calling. So let's do one more example. Very same situation, but this time he goes all in for 284,829 chips. So now do we call? Go ahead and pause it again if you need to, and come up with that ratio. And I'll be waiting. Done waiting. Okay. So I got 360,000 to 280,000. And same thing, I just kind of rounded a bunch of numbers. 80,000 plus 280,000 is 360,000. And then our risk is 280,000. Removed the zeros, 3628. Divided those by 4 again. 4 seems to be a pretty good number so far. We get 9 to 7. We again convert it to a fraction and then to a percent. Risk divided by reward plus risk. Very common theme. Something hopefully that's drilled in your head by now. And we can see that we need 43.8% equity to make the call. And as we showed before, we have this 47-ish% equity if we're doing the rule of 4 and 2. We remember that we have roughly 48% equity, so we should call here. And I said should in both these cases. I'm assuming that a lot of people watching my videos are playing multi-table tournaments. There's going to be situations, let's say for example, let's do an extreme example of you're in $1 million buy-in tournament and somehow you get heads up with this player and you're crushing him. He is just letting you do anything you want, and you get in this situation where you know he has ace king here. You know it's a profitable call, but this is a tournament that's a once-in-a-lifetime deal for you. Most people are not going to be playing more than $1 million tournaments. So saying that this is something that's going to happen over and over and over again for infinity to eventually get to the point where the equities even out is kind of isn't exactly true because of this tournament situation. It's once in a lifetime, and you are in a situation against a player who's just letting you destroy him in most every other pot. So I don't think taking these, even though they're equity edges, even though they're plus EV calls, I think there are situations where you can still even do the math. It shows it's a good call and you can find folds. So that's why I'm saying we should call here. If you're playing, 100 no limit Zoom or something like that, and this is a cash game, you need to be making these calls 100% of the time, because this is going to be a situation that's going to come up over and over and over and over and over. So there, we showed that even though he's betting, what is this now, 4.5 times the pot, we can still call once we have those 12 outs. Okay. So the next thing we're going to talk about is hand versus range equity. So we're going to talk about, this time I'm just going to show an example. We get to the river and we're looking at whether or not we should make a call. So let's look at this situation here. We have queen, and we get to the river and our opponent bets 2 times the pot, and he's a really nice dude and he tells us what his exact range is. So he has aces, 8, 7s, ace king, ace queen, 10, 9, 5, 4, and then 6 extra missed flush draws. So what I mean by extra is they're not a flush draw that has a 10, a 9, a 5, or a 4. So they're completely separate combos, and we're counting those all of his ranges. So first thing we want to do is calculate our reward and risk. So again, I'm going to give you guys a second. And go. So we're getting 3 to 2. So how did I calculate that? This is kind of the way that I calculate it sometimes, is you do pot units. So the pot before his bet is 1 unit, and he bet 2 pot units. So our reward is going to be 3 units, if that makes sense. That's, because we don't have numbers here, right? We just know it's 2 times the pot. So we're not working with exact numbers here. So we're just working in these units of 1 pot. He bet two of those. So now our reward is 3. And we have to risk 2 to win those 3, his 2x pot bet. And again, that same equation that we've shown over and over shows us that we need to win about 40% of the time here to be breaking even. So the next thing we need to do is start counting up a whole bunch of combos and see if we can make a profitable call here. So what combos do we lose to? We lose to all of his aces, his 8s, his 7s, his ace king, and his ace queen. So with pocket pairs, before there's any card removal effects, there's going to be 6. We can see here on this river, on the flop here, there's an ace on the board. So when he has a set possible combo, it always goes down to 3. 8s, 3. 7s, 3. Ace king, there's an ace on the board. So there is 1 removal. The way you do this is you take all the possible remaining cards and multiply them together. So there's 3 remaining aces, 4 remaining kings, because we don't block any of those. So 3 times 4 is 12. For ace queen, there's 3 remaining aces, and there's 2 remaining queens because we block 2 of them. So there's 2 remaining queens. 3 times 2 is 6. Add all these up, and we get 27 combos. And then what do we win against? So again, counting the combos here. 10-9, there's 12 combos. He's deciding to turn his rivered 9 into a bluff. So there's 4 10s that are not removed from the deck, and then 3 9s because one of the 9s is removed here. So 4 times 3 is 12. 5 4, there's no removal, so there's 16 combos. And then those 6 extra flush draws. 12, 16, 6, 44, if I did my math correctly. So we get this ratio of 28 to 44. And what I did here, the actual combos we lose to is 27. That's kind of a number that's hard to work with because you're dividing by 3, where the other number is even, so you can't divide by 3. So I rounded it up 1. This is a pessimistic rounding, again, because it's a combo we lose to, so I gave him an extra combo. So it's going to be, anytime you're making a little bit pessimistic assumption, it's okay. So I made it 28 to give us an easier number to work with. 28, 44. We can, with these combos, we're going to lose 7 times for every 11 times we win. But when you look up here, we were getting 3 to 2. So this means that we can lose 3 times for every 2 times we win, and we're making a break-even call. Here, it's almost, well, I guess we're not going to say flip of that, but if this was 6 and 12, for example, then we could continue to divide by 6. This would be 1 to 2. So every one time we lost, we would be winning 2 times. This is a very, very favorable option compared to what this is. We're now winning more than losing. Here we could lose more than win, and we would still be breaking even. So, boom, easy call. When we broke it down like this into that lose-win ratio. So basically I went over all of the very, very, very simple math that's involved in when you're deciding to make some calls. I did show you the equation for bluffs. It's almost identical, so I didn't feel like we needed to go into a bunch of examples for that. I showed you, very quickly how to calculate your equity when you have using the rule of 4 and 2. And then we kind of put it all together here at the end. Did some combo counting when we're against a range. Showed you how to do that. And then how to calculate whether we need to be making calls or folds. And you can, and hopefully some of this also shows you, this is the reason why a lot of guys that are considered very, very good do a lot of calling, is because, you know, one thing I showed you is when you calculate this, you never need to be right more than 50% of the time, and often it's going to be less than that. So you're just going to be calling a lot, and you don't need to be right all that often to be a break-even to winning player. So hopefully that helped you guys. If you have questions, comments, want to see more in depth, want to see you know, any other topics, you know, hit me up in the comments box, hit me up on stream, on the Twitch stream at WoW Poker, and we'll go from there. And I'm happy to answer questions and make more videos as needed. So that's it for today. Hope you guys enjoyed. Hope you learned something. We'll see you next time.